Hi there and welcome to the Demo Corner. My name is Savannah. I'm an application specialist here at Thermtest. Available on our versatile measurement platform, the MPV with MTPS Anisotropic module is an evolution to the standard TPS Anisotropic module. The standard TPS Anisotropic method follows ISO 22007-2 for measuring axial and radial thermal conductivity and thermal diffusivity of anisotropic samples. Building on the standard TPS Anisotropic method, the MTPS Anisotropic method allows for asymmetric testing requiring just a single sample piece. This evolution accommodates materials with limited sample availability or unconventional shapes and sizes. Understanding directional thermal conductivity and thermal diffusivity in anisotropic materials like layered structures, polymers, and composites is crucial across various industries. Better understanding of these materials allows for optimizing material design as well as enhancing thermal performance and efficiency. Following ISO 22007-7 for thermal effusivity, the Thermtest MTPS offers significant advantages over ASTM D7894, such as absolute multi-thermal physical properties, no contact agent, and testing modules such as anisotropy for expanded use. For our demonstration today, we will be measuring anisotropic compressed fiberglass samples to demonstrate how simple it is to measure samples of this type with the MTPS sensor. Volumetric heat capacity is a required input for this module, which can be measured directly with the MPV specific heat module. So here we have our MPV with our MTPS sensor, and we're going to walk you guys through how to set up a measurement. To start, make sure that your MPV is turned on, and then plug your sensor into the front port of the MPV via the LEMO connection. Next, you're going to take your compressed fiberglass sample and place it on top of the sensor. Now, use the provided weight to ensure that there's good contact between the sensor and the sample. And that's it to setting up your measurement. Now we can move to the software to start a schedule. So now that we're in the software, we can set up all the information needed to run our test. So first we enter the operator ID and then select a save location for the results. Next, we can select the method to run our test. So in this measurement, we would select the modified 3D disk source method with the anisotropic modifier. And in the sample page, we can enter all the information relevant to the sample we're testing. So we're measuring fiberglass with a previously measured VHC of 1.7. The backing material is automatically filled once we select the MTPS sensor. The sample is about 6.3 millimeters thick and has a radius of about 25.2 millimeters. Next, we can check the resistance of the sensor. Okay, so now we can set up a schedule with our desired parameters. So we're going to set up a schedule of 3 measurements with a 10-minute delay using our ITPS function to determine optimal parameters. Then we can just select Start to begin the experiment. So we've already ran some measurements on this sample, so we can take a look at the results in the analysis application. So once the analysis application opens, we can select all of the 4 tests ran to compare the axial and radial thermal conductivities. So here we can see the mean and the relative standard deviation for all 4 measurements. And that's about all there is to running an anisotropic sample with the MTPS sensor or the MPV. In summary, the MTPS with anisotropic module simplifies testing by requiring just one sample piece. Along with other proprietary advancements, we continue to strive for the versatile MPV to be at the apex of thermophysical instrumentation. If you have any questions or want to see your own demo, please contact us at info@thermtest.com or with the information, click the link in the description.